All right, why don't we get started? Thank you all for joining. We have a great session today. Our supply chain only as strong as our weakest link. I think we all have seen recently all the struggles and pains with supply chain. So I think this is going to be of great interest to everyone. And so with that, I will turn this over to the speaker, allow him to get whatever presentations he has available. And um, afterwards, and if there's a pause for questions, I'll be checking the chat to see if there's any questions that are asked that we can relay, and then there'll be a Q&A afterwards. So with that, I'll turn it over to you. Thank you.
Elliot, and welcome everyone. We are very excited to be here. I'm Lori Gordon with my colleague Ron Burke. We are both with the Aerospace Corporation. I am with the Corporate Chief Engineer's Office, leading enterprise integration initiatives internally within aerospace and then also across our government customers and sponsors. I have done a lot of work in homeland security, cybersecurity, and infrastructure risk and resilience, and lead many of our supply chain initiatives at Aerospace. And I have a bachelor's degree in geography from the University of Maryland and a master's degree in public administration from University of Massachusetts in Amherst. And my colleague Ron Burke, also with the Aerospace Corporation, is Associate Principal Director of Development in our Civil Systems Group, working with NASA, NOAA, and other civil agencies. And he focuses on the development of emerging drivers associated with national priorities, strategic planning, and establishing strategic relationships with partners, customers, and collaborators. And he worked at NASA for a long time. He has a bachelor's and degree in physics from University of Notre Dame, and he is also the executive vice president on the board of the American Astronautical Society. So with that, again, thank you all for being here. So as Elliot said, yes, this is a global issue because space is global, and it's beyond space because space relies on a lot of non-space specific components and supply chains. And clearly the space enterprise works with international partners on launch and other space capabilities, and all of these are served by very intricate supply chains. So I'd like to give a quick overview of what we're seeing economically and geopolitically as context for our work on supply chain risk in particular. And these are really the drivers for why we wrote a new paper that we'll be publishing soon through Aerospace's Center for Space Policy and Strategy on this topic. And then Ron will provide the approach that we laid out in the paper, our findings and recommendations, and some significant challenges for space systems by 2030. I'll address some threats that are more near term over the next 5 years. Ron will talk about what businesses can do to mitigate some of these risks. And then I'll round it out by providing some opportunities that we think universities can do now to prepare students to overcome some of these challenges to supply chains in developing the workforce of the future. So economically, 2021, it was another record-setting year for the space economy. More than 15 billion in investment was reported. This crossed all phases of development and operation for large LEO constellations, small sat launch ventures, commercial human spaceflight exploration, in-space assembly and manufacturing, and others across national security initiatives as well as civil space initiatives. And as the space enterprise expands, clearly the threat plane does as well. And so this growing web of interdependencies through supply chains has impacts to both upstream and downstream segments, with the upstream segment impacting space industry research, design, manufacture, launch across that acquisition lifecycle to spacecraft, satellites, and payloads. So you name it, there's a supply chain for it. When you think about the upstream segment that enables applications of downstream markets, those include navigation, communications, agriculture, banking and finance, and power supply. These are all critical to military and civilian users worldwide. Just as a side note, there is a paper that we published called The Value of Space, and it really lays out how all of these other sectors are reliant in some way on space capabilities. So that's something to look into. So the impacts to these sectors ultimately, impacts the availability and slow supply chains. So, for example, we've all heard about microelectronics and challenges we've had due to COVID and the Russian-Ukraine war, as well as a scarcity in supply of commodities, including neon and xenon, critical to the space industry as a result. So specifically talking about the Ukraine-Russia conflict, this really unfolds a disruption to the xenon gas supply, and semiconductor manufacturing companies are really hoarding their holdings, resulting in severe price increases. And this is going to be exacerbated by all the plans for large satellite constellations that are driving even higher demand for commodities such as xenon. Just a case in point, Ukraine's two leading suppliers of neon produce about half of the world's supply. These operations were suspended early in the war, and during that time, we saw some red signs that even if the companies could get back in production, it was unclear whether they could obtain the raw materials to ramp up production. And all those companies elsewhere around the world could ramp up production. It would take them at least 2 years to do that. So in another scenario, that in a situation where limited supply is temporary, those companies may be unwilling to invest in increased production capabilities. So how do we prevent these types of shocks to supply chains in the future? How do we address it globally? And then take those lessons learned in the space sector. So in light of this dynamic, continuously changing picture, supply chain challenges must be addressed through targeted frameworks. We felt the time was now to look at the picture holistically, at the data, the information feeding through systems and processes, and the delta between supply and demand. So as mentioned, the paper that we're sharing and publishing in a few weeks, A Space Supply Chain is Only as Strong as Its Weakest Link, also the title of this presentation here, will be published by Aerospace's Center for Space Policy. And so we're going to talk about some of the concepts that we discussed in the paper. One thing we'd also like to note is that the frameworks we present here can be applied to other sectors. So banking and finance, any of the tech sectors, communications, all of those, agriculture. So that's a key benefit too. So I'm going to turn it over to Ron to provide an overview of the approach that we outlined in the paper and our findings and recommendations. Over to you, Ron.
All right, Lori, thank you. Just audio check.
I hear you.
All right, sounds good. All right, so one of the key drivers for Lori and I looking at this topic was there is a pivot that is happening in the space enterprise. We have a legacy, a very strong legacy over 6 decades of building of the government, in particular, investing in developing, building, and deploying major space systems as tailored development of systems that are specifically intended to serve a government mission. Might be a civil mission like environmental monitoring or space exploration, or maybe defense or other mission as well. But all of these systems that have been developed over the last 6 decades have been what are referred to as bespoke systems that were tailored specifically for a given purpose. And a characteristic of these developments has been that there have been a relatively small number of space systems that have been developed that are relatively sophisticated and are typically developed on 10 to 15-year timelines. In that model, there is, even in cases where there is limited supply of particular components or consumables, there's sufficient time and available funding to be able to overcome those challenges and work through the issues and get the space systems what they need to be deployed. Break. So that's a look back. That's a look in the rearview mirror. As we turn and look forward, the road ahead has a much different landscape. It includes a much larger number of commercial players that are building large numbers of spacecraft, like the proliferated LEO constellations that are being developed for communication purposes. And an interesting characteristic of that pivot to the future is that as we go into into this future, the dynamics of supply chain change dramatically. Not only do we need a much larger quantity of components and consumables, but in typical or traditional production engineering of this day and age, the expectation is that there's going to be availability of the right components and consumables at the right time. So just in time delivery of supply. These factors change the nature of what it's going to take to be able to inform and support the commercial companies that are developing these systems with respect to supply chain. So we've recognized that as we consider this dramatically different future than our past, that whereas let me share a brief analogy here to kind of set the context. So if we take a transportation analogy for a moment, whereas if we're traveling on country roads with relatively few cars and we know our way, we don't need much in the way of aids, map aids, and I'm thinking of things like Google and Waze as applications that give us up-to-date, real-time information based on crowdsourcing that is giving us a dynamically updated picture of the current situation. We just, if you've only got a relatively small number of cars on the road and you know what the travel times are, you just don't need those aids. But if you're, traveling around in DC or Los Angeles or any other major city where the dynamics change constantly, it becomes increasingly beneficial, maybe not essential, but it becomes increasingly beneficial to have tools like Google and Waze that are dynamically updated and inform you as a driver what the conditions are going to be ahead of you. So with that analogy in mind, we recognize the value of being able to have that kind of information infrastructure that is able to be dynamically updated and sufficiently, I'll say, crowdsourced to be credible, so that there's confidence in the information to inform the plans and planning for supply chain consistency and continuity of these increasingly high volume development of spacecraft. In the course of this paper, we've taken an exemplar, if you will, that Lori has introduced, which is thinking about the availability and confidence that we can have in consumables, in particular in the form of xenon gas and neon gas. We also take into consideration the fact that we're operating in a double-blind situation. So not only are we needing to know what the space enterprise demands, what the supply side looks like for these capabilities matched to the space enterprise demands, we also need to recognize that the space enterprise is operating in the context of a global marketplace where the demands and supply for things like xenon and neon can be dramatically different at the global level than at the space enterprise level. And so it becomes important for us to be able to have a way to understand sort of the micro scale, the micro dynamics in the context of a macro environment. So appreciate that I just spent several minutes kind of setting the stage, but hopefully that does a good job of providing a foundation to get into some of the elements that we cover in the paper, including introducing a framework for assessing these supply chain conditions. So one of the points that we make in the paper, we tried to be clever with the title that supply chain is only as strong as the weakest link. And so any place that even the most basic component, down to a capacitor or a resistor or the most basic source of a consumable, if we do run into a situation where that's not available and it's critical to the operation of the spacecraft, then the progress on the entire spacecraft is hindered and impacted. And to Lori's point, there's a cascading effect. If that spacecraft is part of a constellation that's serving some fundamental utility like communications, then we've got that hanging over our heads, so to speak. We have to keep that in mind as we move forward. So what we have done is to taken a sort of racked out, to use a camera expression, tried to take a big picture look at the situation that we're finding ourselves in, and beginning to think about if we had a Waze type solution for the space supply chain, where we could gather dynamically updated data on both the supply side and the demand side. What are some of the metrics, right? Some of the specific elements that we would want to or need to keep track of? And we identified 4 key drivers that we consider to be critical to this process. They're very straightforward, but it's the recognition of the need to be able to monitor all 4 of these, and then after introducing those, I'll introduce the framework that we are suggesting to actually be able to track them. So they are availability, obviously, cost, which can be driven by availability and other factors, quality, which turns out to be a quintessential issue, particularly if a developer of a spacecraft is used to having one supplier and is forced to shift to suppliers that they are not familiar with. Quality becomes a significant area of concern and interest in this overall assessment framework. And last, but certainly not least, is security. So one of the key elements that has proven to be important across the entire space supply chain is the issue of security. And as we recognize that certain components can be limited, forcing a shift to other suppliers, the assessment needs to focus not only on the availability and cost and the quality, as mentioned a moment ago, but also the security and ensuring that that the components, subsystems that are coming online have been through the appropriate rigorous assessments of vulnerability and are secure relative to cyber attacks or cyber impacts. So having laid out the 4 major drivers, we then introduce a trusted, assured supply chain availability assessment framework. And we have a slightly different set of framework assessments that are associated with this framework than the 4 drivers, but they're closely coupled. The first, of course, is for availability is global production and supply assessment. So we have a strong production side and production and supply side. We may not have to worry too much about demand, but the second area that we worry about is the global demand side and how that availability and cost is changing dynamically over time as we follow the performance of many markets and products and consumables. But the third element that becomes significant relative to our discussion here today and to this community is we have to not only think about the global demand, but we also have to think about the space demand in the context of the global demand. And while on the one hand, that's merely a subset in terms of certain types of components and consumables, on the other hand, it can be more significant when we factor in the elements of quality and security, because there are additional requirements and expectations and performance specifications that are applicable in the operation of spacecraft that have to be taken into consideration relative to ensuring that the available sources, even if they are cost effective, or if we have to take into account the impacts of inflated costs, we still have to have specific tools and emphasis on assessing the quality and the context of being used in a space environment. There is quite a bit of energy, and including our colleagues at Aerospace, Allison Yarborough and team, who are looking at being able to extend the appropriateness of the use of automotive quality components for space. A lot of progress is being made there that does open up the channels considerably, but we do have to take those into consideration. And last but not least, we have to pay particular attention to the issues of security. And again, this is another area where we have colleagues at Aerospace working with colleagues across the community, looking at the particular dimensions of cybersecurity for space systems, and we see the value of factoring those in. So having established a description and a basis for an assessment framework, we find it valuable to consider applying a distributed ledger technology or distributed ledger technique type of approaches such as blockchain, so that it's possible to be able to collect information from around the globe on each of these 5 elements in near real time, so that we have the ability to have informed decisions on just-in-time planning of the necessary components and consumables for these high-volume spacecraft development efforts that are underway. So I know we'll get back to some findings and recommendations out of that process, but Lori, over to you to just to highlight any points before we move to that next segment, because that was a lot. You may be on mute.
I was on mute. Thank you. Yeah, so just to reiterate some of Ron's points, we do think the drivers are important to consider in policy circles and academic circles, across the federally funded research and development community, across the university research community, and also with commercial. And we're glad to see a lot of commercial folks on the line here today. That it's really important, because one of the challenges is whenever you're gathering data, there's an expense to it. As Ron said, one of those factors is cost. We're seeing that in terms of embedding security measures early on in the acquisition lifecycle. This is something similar. So there might be a cost associated, for commercial industry that's sometimes, really focused on, well, how do we just get to the moon? How do we just do launch, rather than provide the security and resilience early on in the acquisition lifecycle. So this is sort of a similar concept that we do need to put the cost in. A lot of this is also driven by information sharing networks. So there are several, working groups across government that we are working with, and we know that a lot of you are also working with, to better share information and data. Some of these are around specific aspects, such as focus on launch or ISAM or other areas. But the challenge for us is how do we integrate all of that information together? Because definitely know that these different sort of silos exist across the space enterprise are sharing similar supply chains. And so they need to be talking as well as having that understanding, globally about how supply chains are being impacted as well. So the Space Information Sharing and Analysis Center is one such organization that includes government, industry, FFRDCs, UARCs, and the goal there is to better share information and analysis. Everyone has NDAs, so it's a more free flow of information share. Trying to get that information in real time. It's also looking at, so there's the threat information sharing that they're doing. There's also the vulnerability sharing that they're also doing. That sometimes is harder because it's saying that your system is less secure, maybe to a supply chain incident. As we saw SolarWinds, that didn't come out for a while, but had already impacted a lot of different firms, globally, but also within the space enterprise. And so how do we better take some of understand the drivers and then take the framework elements and apply those now so that we'll have more secure and resilient supply chains in the future. So Ron, did you want to talk through some of the findings and recommendations?
Yes, indeed. Again, just audio check. All good?
Yes.
Okay. All right. So one of the key findings that we have is that it is important to map the interdependencies of different elements of supply chains so that we can keep track of where the potential weak links may be. So just sharing a few of those, that it's important to, to lay down the links, right? So, stretch the supply chain out so we can see it, and identify the stakeholders, where their dependencies are, and make sure that we're taking into consideration all of the elements across the life cycle of acquisition through production and distribution. Understanding the relationships between the stakeholders and suppliers, and the interest of being able to identify single points of failure. We are aware that there are cases where there are either sole suppliers or in some cases, very limited number of suppliers, and any number of things can happen to them, as global conflicts can disrupt those limited availability, but also environmental factors have played in a number of cases where hurricanes or tornadoes or other major environmental factors have in some way significantly impacted the supplier and then have that cascade through the rest of the system. Creating a dedicated space, and play on words here, not talking about outer space in this context, but location in cyberspace for consistent real-time communications. One of the issues that we just do not have in place today is the ability for an impact such as a limited supply of, say, xenon gas to be seen throughout the entire community. And again, back to the Waze example, it does take a few minutes for the GPS signals to build up in Waze to identify a traffic jam ahead, but it's relatively real time. That's the kind of information that we see as being necessary for the space enterprise community going into the future. And then tracking the flow of data about the sources, whether it's information about the quality of the data, the availability, in particular locations for distribution, and any number of other specific factors about the data, are the kinds of things that can be done using distributed ledger technology, and the kinds of approaches that can be implemented and fostered and championed by groups like the Space ISAC that Lori mentioned. Given the nature of this kind of supply chain near real-time availability information configuration. It's recognized that it's complex, highly distributed. I mean, we're talking about supply locations that are global, and at very distributed locations around the globe. And then the value of the aggregated data is available to users, right? The demand side is also distributed around the globe. So taking a measured incremental approach to being able to build up the infrastructure is an observation that we see, that it's not possible to do a step function to get a fully functional a fully functional supply chain capability for all of this kind of capability that we're talking about. We do see that it's important for this kind of a capability to be able to inform and trigger reactions for things that are policies and utilities that are in place, like the Defense Production Act, that need the benefit of being informed and having confidence in the information that's informing them in order for those triggers to be pulled, for those actions to be taken. And we do see the value of taking a national level approach that is coordinated internationally. So this is going to be a global solution that's going to be needed, but there is a value to a coordinated effort at the national level within the U.S. and of course within other nations as well. So we have a recognition through that's highlighted in the State of the Industrial Base 2021 document. There's a lot of good information in that document, but one specific point that they make is that the space industrial base is tactically strong, but strategically fragile. And this is an example of that situation where it can be undermined or impacted significantly by activities that are outside of its direct purview, but that need to be taken into consideration on our collective way forward. So, Lori, thank you so much for that. And if it looks like we do have a question in the chat, shall we turn to that before we continue? So,
you want to take it first?
yeah. So Diane Alexander, thank you so much. How do you see concepts such as an infrastructure in the United States regarding automated vehicles and artificial intelligence impacting the colonies and supply to the moon and Mars? Would it be effective to aid the supply chain in advancing shipping and security? So Diane, that's a great question. It's interesting to note that sort of in related news, we have been tracking and studying the set of companies and government agencies that are investing in capabilities for the moon and developing discrete systems that are part of or contribute to a set of 12 foundational layers of infrastructure that have been identified that are needed in order to have a sustainable cislunar ecosystem. And in the process of tracking the set of activities, we've noted that there are at least 70 companies that are and 10 government agencies that together are investing greater than $7 billion in 2022 in these capabilities. So there is a significant amount of activity underway today that can benefit from this type of supply chain assessment and supply chain infrastructure to support the the development of those areas. And so it definitely will be beneficial to aid the space supply chain relative to the overall planning for capabilities on the moon, and then into the future onto Mars. I mentioned a double blind relative to the space development, that we've got to think, we've got to think, and I was referring and thinking more about LEO and GEO, but as we think about cislunar and on to Mars, we've got to think about the latency issues as well, about the additional level of advanced planning to get the right components and consumables to the right place at the right time, well in advance of need. So, Lori, not.
I'm here. Yeah, I just wanted to add on to that. Some of those numbers, Ron, I think it's important to think about those.
Yeah, Lori, it's commented. Your volume is fading in and out, so if you may have to amplify a little bit.
Yeah, I just did. Can you hear me now, or it's still not?
It's still fairly low.
Okay, I've put it to uppermost volume.
Oh, there you go. Perfect.
Okay, great. All right, thank you. Okay, I just want to amplify some of the numbers that Ron had mentioned. When you think about these 12 different layers of infrastructure that we need to, build to get to cislunar, the moon, and beyond, that's a lot of infrastructure. 70 companies are working on this, putting in a lot of funding. And when you sort of compute all of the supply chains that are needed to support those, the piece parts for what each of those different companies are developing across all those 12, that's a significant number. And it's the intention and the focus really needs to be on supply chain as a security and resilience effort. So I think we're kind of changing the lexicon and making sure that we're really focused on supply chain sort of as a first layer of security, and making sure that we're building that in to components built across the life cycle of each of those 12 layers. Okay, so I think we have a few more questions here, Ron. Let's see. Okay, from Diane Alexander again. Thank you, Diane. Is there a focus within policy that is needed to build now? If you had a sandbox for policy that is congressional oversight free, what would it be with regard to supply and tech development issues? Right, so what we're doing right now, there is legislation in Congress to establish space systems as critical infrastructure. As we all know, there are 16 critical infrastructures ranging from banking and finance to water to communications. The space sector, there's the PNT component, GPS, that is within the communications sector. But in order for space enterprise to get additional funding, focus, dedication, training, resources, it might need to become a new sector or a separate function. So we're working that, and within that, that could be and Homeland Security is working on that with Congress to push that through. And within that, there is a special focus on supply chain. So that might be something that one particular agency has a lead to do. It might be distributed across DoD, the intelligence community, and the civil agency community. But that's one area of congressional oversight that is kind of working through. It hasn't passed yet, but it's just one area, one facet. Ron, did you have any thoughts on that one?
I think that's really good points. We are recognizing. I appreciate the reference to sandbox, and of course that's a approach that is used in software development, and in particular is beneficial in an agile development approach. That there's an environment to test, to quickly develop and test constructs. And that does lend itself very well to the recommendations, the findings and recommendations that we have. that it would be beneficial to use a sandbox environment to develop solutions and test them and make sure that they work in order to make as much progress as possible, as fast as possible, without having long drawn out sort of bureaucratic processes, first to fund a solution which may or may not work, and then to get it approved. That sort of taking a page out of the Agile development book could be a much better way to move forward faster. So yeah.
Ron, I think it could be concurrent. So, for example, the Space Information Sharing Analysis Center has a supply chain working group, and they're doing a survey of the space enterprise on some of the challenges that the space enterprise, from large commercial companies to very small startups, are having with supply chain, and what policies and programs are they implementing that currently exist, and then also where do they see gaps in those policies. And so that's something that is also concurrently working through, in addition to this policy that's trying to move through Congress. So we have another set of questions from the Whova app audience. Thank you all. Let's just walk through these in a sequential order. The first is, will space-based supply chains be legally separated from ground-based supply chain ops? So I'll take a stab at that one. So I think one of the things, and we're getting ready to have a conference at Aerospace in El Segundo. Well, actually, there's 3 that Homeland Security is putting on. One's in El Segundo at Aerospace headquarters. One is at Kratos in Colorado Springs, and one is at MITRE in Arlington, Virginia. DHS is asking this same questions. It's a 4-hour seminar asking, clearly, and I mentioned this earlier in the presentation, that sometimes and often the different let's just call them subsectors within the space sector, launch, ISAM, space traffic management, sometimes they're working in silos. And, how do we ensure that they're all sharing the same information, because they might be sharing the same supply chains. So I think similar to this, there might not be, it might be better to, the space-based supply chains and ground-based supply chain operations, that information that's shared in terms of threats and mitigations might need to be shared. One challenge, though, is that ground-based supply chain operations, that said, ground-based supply chain operations have always been a challenge, right? Because they're accessible, supply, and I'm mainly thinking of cyber supply chain risk management, which I'll talk about a little bit later. But they are sort of the subject, an easier target than space-based systems and supply chains. So I see that point there too. But I would say that the information sharing needs to be there about the threats and vulnerabilities and potential mitigations, just so we have sort of a backstop in case the space segment may in the future see some of those challenges that the ground-based systems are seeing. Ron, did you have any thoughts on that?
I think that covers that quite well. Yeah.
Okay.
Let's go ahead, please. Yeah, let's keep going. These are good questions.
So students need to understand about the supply chain and how to address these issues, no matter the industry. Yes. How would this be addressed to help make business connections? So, from my perspective, I guess I'll jump in. One challenge, and I think this is getting better. The space enterprise in each of the sectors are the upstream and downstream have been sort of a little bit isolated. Been isolated in the past, and now there's greater. They realize that they need to have better visibility into what the communication sector is doing more broadly. For example, we just wrote another paper on the global communications infrastructure. So the space community and the undersea cables community are all part of this global communications infrastructure, but those two groups don't necessarily talk as much. So we're trying to bridge the gap there. And in terms of, I think that's a critical notion or insight for students to be able to understand that, it's not, even though you're getting a degree, you know, in a space-based application, that it's important to understand these other quote unquote industries like undersea cables that are tangential or interdependent in you know, the space enterprise. Ron, did you have any thoughts on that? And I think making business connections, it's through venues like this, sharing through the Whova app. It's sort of expanding your network, you know, and, you know, maybe it's not necessarily, you know, within the space enterprise specifically, but, you know, being an advisor to, you know, the undersea cables community from your space background. All right. And then the
Yeah.
third.
Yeah, if I may, yeah, Lori, I think an area, an approach to establishing business connections that is proven to be very effective is participating through professional organizations, in particular AIAA, IEEE, and the American Astronautical Society are all excellent venues and platforms for being able to make business connections. Yep. Okay.
And then the third question is, what logistics are we looking at for space operations in the future? The basic satellite ops is one thing, but Moon and Mars. Ron, do you want to talk about some of this, Leonard?
Absolutely. I love this question. Yes. So hopefully, for benefit of the participants here, I shared another paper that you may find interesting that was recently published through CSPS on charting a course through cislunar master planning, which really takes a hard look at this issue. One of the dimensions that we have is that with so many different organizations investing in, developing, and planning to deploy capabilities for the cislunar domain, we do have to be paying attention to not having those sort of cross wires, to actually having those stakeholders, if you will, come together and share what they're planning to do. The lighthearted analogy I've shared on this topic is, you know, you need a master planner for an industrial park, because you wouldn't want to come in and lay out the road network, only to come back and tear the road up to put in the communication network, to come back to tear it up to put in the water and other lines. So similarly, there's a value to coordinating the activities on the path to laying out capabilities in the green field of the cislunar domain, the moon and around it. In addition to that, one of the key areas that is recognized that early planning needs to be done on is depots. And, you know, I've been trying to use analogies here to put things in perspective. You know, who's planning the 7-Eleven for the cislunar domain, so that, you know, when you get out there and you need to stop and get some fuel or some xenon gas to go with our exemplar and a Slurpee, where are you going to go to get that? That all has to be pre-positioned, and aerospace in concert with AIAA and a number of companies recently held a workshop to think through the particulars of that and lay out a roadmap for how to get that first cislunar depot in place, what should be on it, what should be available, you know, in that location, when it should be available, and begin to think about some of the interoperability issues. So I offer that those are all part and parcel to the response to that question about logistics for space operations in the future, particularly in the cislunar domain. Over.
Thanks, Ron. I just want to talk into Michael Wall's comment. Totally agree. He says absolutely the connections from these sites makes life better and brings in great numbers of people otherwise not known or accessible. Absolutely. It's just extending the network that we have. So that's fantastic. Thank you. So thank you all for that engaging dialogue. I really appreciate that. Excellent questions. glad that we've had some time to think through them. So, okay. So Ron, over to you again to ask what you see as the most significant challenge for space systems by 2030. And then I'll talk about after you what we're seeing more in the near term over the next 5 years.
Great question. Have given a lot of thought to that. And I think the biggest challenge for space systems out to 2030 is interdependencies. We have a legacy of space systems that were designed with the limits of the fairing size of a rocket, right, as the primary constraint. So everything that was going to go for a particular space system had to be configured to be fit into a fairing. And one of the more awesome examples of that was James Webb Space Telescope, which was folded up like origami and put into an Ariane 5 fairing. But that's about as big as you can get in one launch. We are moving into a future where it's intentional that we're going to have in-space servicing, assembly, and manufacturing. That things are going to be built up in space, even manufactured in space. We've got a company by the name of Icon 3D that is developing a 3D habitat printing habitat, right? Home facility printing solution for the moon using the moon's regolith to build it. My point here, though, as exciting as that is that the challenge is how are all of these different systems going to work together and be symbiotic with each other in order to have a sustainable ecosystem. It is absolutely essential that everything support everything else. And the challenge is that there's no foundational mechanism yet, it's the operative word, for all of those communities to have the appropriate coordination to make sure that they're all using the same metric system or the same measure system, whether it's metric or other, and that all of the different communications, ECLSS, transportation, and every other kind of system that is involved is sufficiently interoperable with the other components that it doesn't prohibit the progress that we're seeking. Great question. Lori, if I can flip a question back to you. So where do you see the threats to the space supply chain over the next 5 years?
So I want to talk a little bit about cyber supply chain risk management because we are seeing the threats and vulnerabilities from that every day. We've seen it, for a decade. It was interesting. There's a NIST special publication 800-161 that was published, I think it's probably 12 years ago now, right when they started seeing, in general, a lot of cyber supply chain attacks come online. That is the ground station segment. It applies to that, right? Because it's all domestic terrestrial focused things. The challenge was that there was no framework or publication that could be devoted to space systems. And so we're working with NIST on that right now to better understand what is the framework. It's modeled off the risk management framework and the cybersecurity framework that they also have, but it is specific to supply chains or this, space challenges and space cyber attacks. But within that, there's a lot of discussion on supply chain for the space segment because we're seeing that adversaries, the cyber intrusion into the supply chain can have significant impacts. More broadly, we saw solar winds a few years ago, and then we see network attacks all the time on the space segments, ground, space, uplink, downlink. And so the other challenge here is that's compounding this is the commercialization of space and the inclusion of and more common use of off-the-shelf components. And this means that all satellites are vulnerable to cyber intrusion, even if one part of their shared supply chain is corrupted. So, this in addition to the threat of supply chain intrusion, as well as just cyber attacks in general, we're seeing that the consequences of supply chain attacks from adversaries could be wide-reaching. So one thing we've been working on, and this is it's more of a tool for operators to use, is Aerospace is developing a framework. It is called the Space Attack Research and Tactic Analysis Matrix, and it's designed for the space enterprise. It will include a myriad group of tactics, techniques, and procedures so that space developers and operators can understand how threat actors could attempt to attack their spacecraft. So this is focused on spacecraft. This is the space segment. And while it covers all space segment TTPs, nested within that are supply chain TTPs. So it's very useful to be able to understand what's the art of the possible that threat actors could use to disrupt the supply chain to space vehicles. So it will allow us to identify, categorize, and see a range of mitigations for each TTP impacting cyber supply chains. Basically, it's called SPARTA, and it will serve as the basis for testing the efficacy of security solutions in environments, ground systems, and onboard spacecraft. And really, it's a common taxonomy for offensive and defensive space cyber postures and vulnerabilities. So that's something I just wanted to make sure that we touched on in the near term, cyber supply chain, because in some ways there's more bang for your buck, or you'll have more impact by initiating a cyber supply chain, a cyber attack on the supply chain. So, because that has an immediate ripple effect. So I don't know, there might be questions on that. I'm happy to answer, but I just want to turn back to Ron and ask, based on the threats that we're seeing, what can companies do now to prepare for these challenges and threats?
Yeah, another great question. Three things have sort of come to the fore. First and foremost is to recognize the value of coming together as a set of companies and paying attention together to the threat vectors that are sort of impinging upon them, because an issue that one company faces that's rapidly communicated to all the other companies is going to minimize the impact. If that, of course, doesn't happen, and the same threat can or risk or impact can affect many different companies before they have a chance to respond to it, that's much more detrimental. The second is having a focus on standards and best practices that is also shared across the community. It has proven to be effective that when multiple companies and organizations are sharing in a common approach to protection against threats, that the impact of those are lower, and if they can standardize those approaches in such a ways that they're easily replicatable, that is definitely optimal. And the third, which is highly related to these two, and is really the focus of the discussion here today, is to leverage information infrastructure, information and communication infrastructure, to be able to share information as quickly as possible. Share and aggregate. Let me emphasize the and aggregate part, because Lori, if my space system runs into a problem and I share it with you rapidly, that's good for both of us. But what about the hundreds of other, right? What about our other 15 people, 14 people on this call? How do they find out, right? So the question is, or the opportunity here for companies to prepare is to have the basis of being able to have aggregated information at their disposal at the speed of need. Yeah. So with that, I'll flip a question back to you. So what can universities do to prepare students and develop our workforce of the future, taking all of these things, keeping all these things in mind?
Good question. Particularly appropriate audience, so happy to share.
You may be on mute.
Oh, I don't think you can hear. Can you hear me now? I'm not on mute. Can you hear me?
The volume is just really low for some reason.
Okay, I turn it. Can you hear me now? No?
Still low.
Okay, well, I'll just present anyway, and maybe it will start working. So again, as we advance our technologies, research, and operations, and given the expanding space economy that we discussed earlier, it will be important to understand the jobs of the future. And so NIST, yeah, I'm sorry, I can't help. I don't know what to say here. So NIST has developed a workforce framework for K-12 to higher learning and return to work, and developed a chronology matrix of all the job types in the cyber community. And this could be a good model for space and supply chain. And also the collaboration and partnerships between academia and the space enterprise to include the rapidly expanding commercial space sector will be critical.
All right, sounds good.
Yeah. Wait, two more things.
Please.
And then engaging with new and emerging information sharing forums, including the Space Sharing and Analysis Center. We're having October 18th, 20th in Colorado Springs at the National Cybersecurity Center at University of Colorado. A conference on the value of space, and we're inviting students to come for free. So just wanted to share that. And those are sort of what I was thinking through. I'll type my over.
Okay, appreciating that we are down to 5 minutes. Elliot, would you like to sort of summarize and wrap us up, or should we take another question?
No, I'm certainly going to leave it to the experts to summarize, right? But basically, if you guys have another question that you can answer, and there's 5 minutes, that's awesome. So
Okay.
if anyone else has any questions, please either ask them now or note them in a chat. We'll try to get that answered as we wrap up these last few minutes.
All right. Well, shall we take this question from Diane, which reads, Space Force acquisitions have offered resources for increasing military comms center security and services through the Sherpas. Is that program prohibitive due to military civilian issues or beneficial for optimizing security? And appreciate your appreciation, Diane. While we're not in, or I am not in position to respond relative to the Space Force program, I can offer what may be beneficial response in a slightly larger context. That one of the engineering approaches that we have recognized is beneficial to this entire process, from acquisition through development, through operations, and even out to disposal, is the use of digital engineering techniques, which are proving to be useful in being able to be applied back to the sandbox concept, and actually develop capabilities, develop systems in a digital domain, and be able to test and evaluate the viability of the solution, the engineered solution in the digital domain on the path to producing a physical representation or instantiation of the digital approach. And that the U.S. Space Force has relatively recently come out with their Space Test Enterprise vision, which is focused on the use of digital engineering infrastructure as the basis of both testing as well as training. And what's beneficial about that is that it's easier to share access to digital information. It's also possible to be able to test more comprehensively against a wider set of security issues. So I'll offer that as a solution. And interestingly, we have another paper on that topic, which I will put in the chat. I put a couple of other reference papers in the chat as we've moved along. Lori, additional thoughts?
It looks like Lori's video went out because of connection.
Oh,
You can probably wrap
so-
it.
yeah, so sorry to see that. Okay, so I think, but at this point now we are down to 1 minute. So Elliot, certainly over to you to bring us home.
Well, this has been a very informative talk. I certainly appreciate the presenters, yourself, Ron, and Lori. I appreciate for all those that came and listened to this this very informational informational presentation on the supply chain. And this has been recorded and will be made available. I thank everyone for your time, and special thanks to the presenters for again for doing such a great presentation. Thank you very much.
All right, thanks all. Take care.